Today in class on Tuesday, we had a kind of a work session where we created our own phase change diagram. So I'm going to give you a big sheet of paper. So if you were not here, you need to get a large sheet of paper that I have on the front desk. And we're going to make, this is kind of like on your reading, page 2 has a bunch of little diagrams. This little diagram can be found not exactly like this, but it has the solid, liquid, gas, plasma, and it's like a stair step. It's like a ladder. And then it also has these arrows showing your phase changes. So you're going from solid to a liquid is called melting, a liquid to a solid is called freezing. So those are on there as well. And also in your reading, what you'll find is something about the energy levels, and we talked about that in class too. So you'll notice that I colored mine. You don't have to color yours, but you do need to have this diagram where you have the phases. The other thing you need to do is you need to be sure you have the arrows and have them labeled. And the other thing you need to do, third thing you need to do, is you need to show your particles. Okay, so show your particles of a solid, your particles of a liquid, particles of a gas. And notice this particle of a plasma, you have your little free electron, so don't forget. And on this one, I just for fun did not put the top on my container, so I showed that these are sort of escaping that container. So those are some things that I want you to do. Those are the basics, but the main thing here, you'll notice that I use different colors. You don't have to use different colors for these words, but you do need to understand, this is kind of the high school part of this, is what's happening to the energy level. Am I adding energy or am I removing energy to get it to go from one phase to the next? So those arrows that are right there, I chose to use red for adding energy, because red kind of like adding heat, things that are hot. I think of things that are hot are red. Blue for removing energy, because I think of things that are cold and ice. That's blue. I don't know why. Snow blue, kind of blue white. I don't know. You don't have to do that. You might even want to note on yours, maybe with a plus or a minus sign. You can see here like ionization's in red, so I'm adding energy. So if you don't have colored pencils or crayons or markers, so you could just note that that's an adding of energy. And then on your legend, you would put like a plus means adding energy instead of the arrow there. So those are the things they're going to do, and you can make kind of large, you can make it colorful. So again, the names of each phase, the names and arrows of the phase changes, and make sure they're pointing in the right direction. Remember, if I'm going from a solid to a liquid, that would be melting. That's not freezing. A liquid to a solid is freezing. So be sure you have those labeled, be sure you have your particle structures, and be sure you've noted somewhere, somehow, about the energy level changes. So that's part of one. And then on the other part of this sheet, I have to fold it in half because it's a real big sheet, so your sheet's going to look like this. It's going to have two things. On the other part, we are going to do the phase changes of water. Again, on page 2 of your reading sheets that I handed you, you have a diagram that looks like this, but it does not have temperatures. But it does say heat added, which is the same thing as energy added. But it's very similar in this shape, where you have a slant, a flat line, a slant, a flat line, and a slant. And it's showing that everything, no matter what the substance is, goes through these phase changes. So it starts as a solid, it's going to have a melting point, it's going to change to a liquid, it's going to have a vaporization point or a boiling point, and then it's going to change into a gas. If I'm looking at it going this direction, which you don't normally, but if I'm going this direction, I'd be going from a gas to a liquid, so this would be my condensation point. This would all be liquid temperatures, freezing point, and then back down to a solid. So if my energy is being added going in that direction, obviously my energy is being taken away going in that direction. Don't forget to label your temperature in Celsius. So what we're going to do is we're going to make a graph that shows the phase changes of water specifically. And if you know the properties of water, water has specific freezing points and specific boiling point. It's a physical property of water. Water is going to freeze at 0 degrees Celsius. So you notice what I did here. I started at -10, I went to 0, and I made my slanted line, and I labeled that a solid. And then I went from here to here. It doesn't really matter how large you make that space. It's all going to depend on how quickly you add this energy. And this this part here is going to be your melting point, generally. If I'm going the other way, it's going to be your freezing point, which is interesting because that's one of the things that students miss sometimes is they don't realize that melting and freezing actually happens at the same temperature. So at 0 degrees Celsius, I would have solids and liquids present. I wouldn't have a solid hunk of ice, and I wouldn't have a liquid glass of water. I would have maybe some slushy ice crystals somewhere in that water, and of course some liquid particles too. So depending where it was. So the temperature stays the same even though you're adding energy. Then you have a liquid, and you notice this one here, because I counted by tens, this liquid's kind of steep here. The majority of this is being shown as a liquid. And when I do this, my liquid lines up until I get to about 99 degrees, and then it flatlines. So at 100 degrees, it flatlines. So there's your phase change. And at this point, depending on which way I'm going, if I'm adding energy, I'm vaporizing to a gas, so I should have some liquid and gas particles. If I'm at a gas and I'm taking away energy, I'd be condensing. So I'm vaporizing and condensing at this point at 100 degrees. And when they name that, they call that the boiling point. The boiling point of water is 100 degrees. So we've got liquids and gases. And then after you get past that, so you have to be like at 101 a little bit, right? Just a little bit, and it doesn't have to be exact, but then it turns into a gas. So again, the temperature stays the same, but notice that here our energy is being added still. And we talked about that in class yesterday, that as you during phase changes, the temperature does stay the same, but the thermal energy would change. So the thermal energy that's being added here is actually being used to overcome those attractive forces. So if you remember, we've got attractive forces holding those together, and they're vibrating slightly in a solid. So once you have it breaking free, during that time when you're phase changing, it's using that to overcome those attractive forces, even though it's not changing in temperature. Once it's all changed from a solid to a liquid, the temperature would then start going up and rising again. So that's what I want you to do on this big sheet of paper, and you need to have two graphs, your phase change diagram and the phase changes of water.
Jayla Moffett, come to the front office, please. Jayla Moffett, come to the front office.